So welcome to the 10-Star House for another episode for the Coffee at 10-Star House series. So I'm here today with Jackson Digney from Climasure, who is one of the partners on the project. And we're just going to have a chat to him today about his involvement and how he's contributed to the project, but also the education behind the project too. So welcome, Jackson.
Thanks for having me.
You've had quite a long-standing relationship now with SUHO over the years, so we've built up quite a bit of trust and honesty in terms of
You're too kind. Yeah.
Constructive methods around construction.
Yep.
Can you describe your involvement in the project and why you wanted to be involved in the 10-Star home?
Yeah, so I was keen about being involved because it was a chance to, particularly for me coming from more of a passive house background, to actually see and be involved with the process of developing a 10-star design and going through the knickknacks of actually getting the NATHA's software to go, yeah, this is a 10-star. And it was a great opportunity to sort of put forward my ideas and see how they worked as well. So yeah, I was excited to be involved.
And I know that we've had many discussions comparing passive house to star ratings and the importance, especially as Geraldine, who's from the studio as well, about not focusing on one or the other. Obviously we had the 10-star objective here, but we also understood, and from discussions with you and the consulting on site, that there were certain requirements around the membranes and things that were quite important for this house. Can you describe the changes in the MCC and why it's important to actually consider different methods in terms of membranes and airflow?
Yeah, so one of the things about the new building code is that it's mandating a level of airtightness. And what often has happened in other parts of the world where building codes have changed and mandated airtightness without considering condensation is that their builders or industry has reacted by using the materials they've already got and taping them and gluing them and making the house more airtight just using regular materials.
Yes.
And that's resulted in a really non-scientific approach to fixing a compliance problem. And what got me involved in ProClima and selling ProClima membranes is that I went searching for a way of being in front of that problem occurring, because you don't have to look very far or search very hard to see where what we're about to go through in Australia has already happened before all over the world.
Yes, yeah.
So what the importance of using a proper membrane on the outside of your house is that if you make a house more airtight, then the air is exchanging from inside to outside more slowly. Now this is a good thing for energy efficiency, because if the house is airtight, then the money you spend heating and cooling the air in there, that the air stays in the house, and so you don't have to keep spending more and more money heating up, for instance, in winter, heating up all this cold air that's leaking in. And the problem is that because that air is not being exchanged with outside as fast, then you can have a situation of high humidity inside the house, which puts more of a humidity load into the various building elements. Now, humidity finds its way out through walls all the time. It's a really slow process, but it occurs. And if you've used a solid sarking material on the outside of the walls, then moisture can get stuck on the house side of that solid material. And then you can have a situation where that turns into condensation, and then that condensation in the right conditions can become mold.
Yes.
Or can rot out timber frames, for instance. Or if you've got a steel frame home, then it would rust that out. So by putting the right type of membrane on the outside of your house that is airtight but vapor permeable, then you get the best of both worlds. You stop air from rushing across your insulation, and you're also allowing that higher moisture load from inside a more airtight house to get out. And that's kind of it's a simple way of getting compliance without getting into things like HRV systems and more passive house stuff. It's just like put the right wrap on the house and you can assure yourself that you'll hit the air tightness requirement, but you can do it in a way that doesn't create a liability for you as a builder or as an architect specifying certain wall systems. And one of the other key things is that when you, for instance, the common building method in Australia, brick veneer, like that's kind of where you start with everywhere. So brick veneer is, and I've heard this from various, some of our trades have built with volume builders, and they have bought membranes from us after asking whether, what sort of wrap are you putting on the house. And one of who was actually our bricklayer, he built a house, and the answer that he got was, well, sometimes we do and sometimes we don't. It just depends on, where we're at scheduling wise. Wow. That's like the least scientific way to do it.
Yeah.
So he actually bought the membrane and put it on himself. What can happen is that, say you are building a brick veneer house and your builder decides, look, we don't need to worry about it because we'll get the brick up before the weather comes. We'll just whack the insulation and she'll be right. Well, then your insulation is exposed to air movement. And the best way to describe how the membranes help with insulation is using a jumper analogy. So if you're standing outside in sort of a regular sort of cotton hoodie on a cold, windy day, you'll feel every bit of that cold wind, right? You may as well just have nothing on. So, but if you put like one of those plastic ponchos over your head, then you'll feel warmer because the wind's not pushing all of the heat from your body warming the jumper up. That's getting pushed through. You put plastic over it, that stops and you'll start to feel warmer. But you'll also find that there's nowhere for all of the sweat to go. So then what you do is you take that off and you go, I'll put a Gore-Tex jacket on. Mm-hmm. Now, both things are ultra thin. The difference with the Gore-Tex jacket is you get the same result, you stop to the wind, so you start to feel warm. Then you start sweating, but you don't notice it because that vapor that is coming off your body is going out through the membrane, which is the Gore-Tex jacket, out to atmosphere where it's safe. And so the ProClimate membranes do exactly the same thing. It's the same thing.
And for the layperson that might not understand how the humidity is created inside of the building, do you mind explaining that?
Yeah, that's easy. So just us standing here breathing, if there's like a light breeze going past, if there was no breeze and you measured the humidity between the two of us and you measured it a meter away, there'd be 2 or 3% difference maybe, because we're breathing, which means there's moisture coming out in what we breathe out. We're sweating because the sun is hot and we're both wearing dark shirts. and then so you put that inside so that there's a moisture load there from the people in the house, and then you turn the tap on, and just even a cold tap, there's some degree of moisture vapor coming from the water as it, the molecules of water hit the basin and break up. You'll get some vapor release, and then of course there's the really obvious ones like boiling water on the stove, boiling the kettle, having a shower. If you've got an older dryer, putting the dryer on, washing machines, dishwashers, they all put out moisture, and that's where that moisture load in the house comes from, in addition to whatever your relative humidity is outside. And
it needs to get out of that building.
Yes.
So it does. And I know Sustainable House Day last year we had the home under construction, which was really good because we could see a lot of those membranes in action. I know that you came on site and you did a lot of training with the trades because for a lot of trades currently there's not a whole lot out there that have such intricate training on air tightness as well. Yeah. Can you describe your involvement in terms of training and the methods that were used in terms of giving that communication?
Yeah, so a really important thing about making the investment to put a proper membrane on your house is installing it properly. And amazingly, it's none of this is rocket science. None of it is difficult, and every single carpenter that I've trained, and architects and builders as well, they all get to the first hour into the training, they go, "Oh, this is easy."
Yeah.
I'm like, "That's what we said. It's
not rocket science.
No,
building science.
No, that's exactly right. And the actual practical side of putting everything together. So every time we sell a house lot to someone new, I go out and train their guys on how to install it. And there's a couple of really simple techniques and a couple of kind of methodologies to understand about what to do in different situations with taping or gluing, or what the right product is to use. And I find usually within a couple of hours, most people are completely across it. Yeah.
And for those that don't know, Jackson actually does training on site. So if you're keen to see an actual construction site and learn about these sorts of membranes and how to put them in, get hands on.
Yeah, so we're looking.
Gun. Really
you had a good time.
And it's immersive, which is the best way for people to learn.
Yeah.
Because it breaks down barriers of people that don't learn through different literacy or visual means.
So the training days that we do, we invite everyone out. We're sort of looking to trying to do one October, November time. And they're open to anyone who wants to come, and they're free. And we sort of put on a day of training, and we talk about not only the practical side, but we also give a lot of information about this is why you do it, this is how they work or don't work, and these are some of the things around the building science of what goes on beyond the membrane. Because one of the other things that is often missed is ventilation, and it's important in a wall system to have ventilation zones. So I talked at the beginning about you want to make the area around your insulation airtight, vapor permeable still, but you also need to create a space for that vapor to get away.
Yes.
And so the way I put it is, we want to get the vapor to the outside of the membrane where it's harmless, and then vent it to atmosphere. And so one of the other key things is making sure when you're designing a system and you're thinking about, we want to use these membranes, we want to get a nice airtight house but not cause a mold problem, we need to make sure that you allow some batten space for ventilation between the membrane and your cladding. And that actually helps to improve the effective R value of your wall, because by putting an air gap in front of the membrane, you create a little bit of a space that reduces the radiant heat from the sun onto the outside edge of your insulation, which means that, I say, more of your insulation is cooler in summer, or warmer in winter. So.
Okay, now in terms of information for homeowners, when you're designing a sustainable house, it's important to have a bit of a dialogue with your builder and your architectural designer about what your objective is on the house, how you're going to use it. And one thing that plays into that quite heavily is air tightness. And you mentioned air tightness before. Can you describe what air tightness is to the layperson?
Yeah. But
also the different sort of levels that you might go to depending on what your occupation is, how you're going to use the house.
Yeah, and budget as well.
Yeah.
So air tightness is measured in a couple of different ways. The easiest one to describe is air changes per hour. So air changes per hour is always measured at 50 pascals of pressure, and 50 pascals of pressure is the easiest way to sort of put that in layman's terms is to say, if you're standing on the beach in a sea breeze, the pressure that you feel on your body from a sea breeze, that amount of pressure is placed on the whole house to get that 50 pascals of pressure. And then what happens is that's done with a blower fan, and the fan can then register the difference in pressure from inside to outside and calculate the amount of airflow that's actually leaving the house for the speed that the fan's spinning. So it goes, if the fan's spinning at 1,000 RPM, it should be moving this much volume of air, but it's actually only moving this much volume of air. Therefore, you divide them and you get the air change rate in round terms. So the thing about air tightness is that it's really one of the like fundamental things in energy efficiency. You could use all the fancy pants products in the world, but if your house leaks like a sieve, you've wasted all your money. You may as well have left the insulation on the truck, left the double glazed windows at the factory.
Yes, yeah, absolutely.
Don't worry about any of it, because if your house leaks like a sieve, it was a complete
Waste
waste of money.
Yeah.
So when you make a house airtight, like we talked about, you can you increase your risk of air quality problems as well as the risk of condensation forming. Now, there are certain thresholds where you can kind of get the best of air tightness without some of the additional risks. So when we talk about air changes per hour, or ACH, we look at a house that's between 3 and 5 air changes per hour as being the best bang for your buck without having to get a heat recovery ventilation system and still having a healthy quality of air in the house. So you don't have a very high free air movement. And of course, for someone with allergies, having a leaky house, so greater than 5 air changes, yeah. So you would notice the change in season a lot more.
Absolutely.
Now, if you go under 3 air changes per hour and you don't put a heat recovery ventilation system in, then you have a very high risk of CO2 buildup, which is of course not great.
Yeah.
So you would then put in a heat recovery system, and what they do is bring fresh air in from outside and push the air that's in the house out. So you're getting a constant level of fresh air. Now, lots of people go, why don't I just have a non-airtight house? Like, well, what's the need for all that?
Yeah.
That just seems completely crazy. Like, well, it's not. And the reason that it's not is that with a heat recovery system, you're bringing fresh air in and filtering it, and you're improving the quality of the air in the house by doing that. And you're in control of the air that comes into your house. So if you go to full passive house spec, then you're aiming for 0.6 or less air changes per hour. But anything under 3, you're starting to be so in control of the air in your house that you obviously need to change it over to keep it healthy. It also means that when you're have a nice day like today, some people go, well, we like having the windows open. Like, that's no problem. Yeah. Open your windows, enjoy the fresh air. And when your allergies kick in, close the house up, put the HRV back on, and you're back in control of the air that's coming into your house. And that's the key thing, is control. So, and always we have to balance budget with performance.
Yes.
And so that's why if we're just going for that 3 to 5 air changes, then what we recommend is we'll just make sure you get your walls right. So put a membrane on the outside, make sure that your plasterboard is really well sealed to the inside of the frame, and then that way the insulation in there, it's like your hoodie with the Gore-Tex jacket over. It will work the way it's meant to work. And then there are various levels up from that. So another level that isn't quite passive house, but needs an HRV, is using a roof wrap as well that's connected to the wall wrap.
Yes,
so
tacked all together.
Yeah, that's right. So we make the air tightness occur on the outside of the building, which again is it's if you look at it from a purist passive house point of view, it's like not an ideal solution. But to suit a homeowner's budget, it's a way better solution than just whacking a bit of silver sark on and maybe some builder's blanket on the roof and just hoping for the best. And then of course the next level from that, which is another jump in cost, is a passive house spec. And a lot of people will often say, oh look, we don't want a passive house, they're expensive. You're like, are you talking about the cost to build it or the cost to certify it?
Yes.
And
The build cost is only, I think, proven to be about 5% or something more.
Yeah,
and you're not having as much energy. Is that right?
Yeah, that's right. So, I mean, the cost increase always depends a bit on the size of the house and the complexity of the house. That said, though, you can always, and the good thing about passive house is it's a scientific approach. So we can look at, okay, your energy savings will be this much, which if we just look at your power bill, then your return might be over 10 years, but that's just looking at one dimension, which is your power bill. But then you've got to look at, well, how many days of work do you lose? And not ones where you can't go to work, ones where you go to work, but you're not at your best because your allergies are getting under your skin. And interestingly, when I grew up in WA, really bad hay fever till I moved over here. I live in the Adelaide Hills now.
A lot of SA people moved to Queensland.
Yeah. It's crazy. Like, I live in the Adelaide Hills, where that should be way worse than growing up on the beach in Perth. And I don't have allergies anymore. But I remember in Perth going to work and just my allergies were so bad that I knew that I wasn't working at my best. And so there is actually an economic cost to that. And so when you put all of those things together, suddenly you go, oh, hang on a minute, this actually makes sense.
Yes.
So it's why if you're looking at your budget for your house, and you're like, we want to do it better, it's worth exploring all three of those options in the context of the whole of the house and all the other things you want to do, like stone bench tops or laminate bench tops or $300 taps or $80 taps. And so, because you can go through and you might be able to trim down in other areas on things that you'll probably get bored of in 10 years anyway, and put more of the money into the structure of your house and what you're doing with insulation and membranes and cladding, and then do what you can with all those finish things, because like I say, changing finishes, nearly everyone eventually gets bored. They get bored, or their kids have broken the same cupboard door 6 times in the kitchen over the space of 5 years, and they're like, you know what, actually we wouldn't mind getting a new kitchen. So all of that money that you put into a kitchen when you built your house and scrimped on energy efficiency things, it was a waste anyway.
And in terms of this house, so we've done the ventilation behind the cladding, and then we've got a membrane. We've got a service cavity in the roof as well. And in this one, we've used OSB. I believe when you were training on site, we've actually taped the membrane to the top plate and also to the OSB, so that we've got that layer. So is that a typical construction method, or is that something that you and Geraldine kind of brainstormed and worked out on site in terms of actually getting the logistics of it to work? Yeah,
so using OSB on the walls is it's looking at the whole budget for the whole house in a holistic way rather than just hitting on one point and ignoring the rest of it. Mm-hmm. So by using the OSB, you get bracing benefits. It also has some practical applications. Like if we put OSB on the walls or the ceilings, it makes it a lot easier to fit the membranes too, and protects the membranes from damage from a windy day on site. Obviously, when you're halfway through building a house, the wind goes through everything. So that there's some practical applications to putting OSB on, and you always have to kind of weigh that against cost. Like, if we put this OSB on, what are we actually going to save? And sometimes with bracing, you can sometimes avoid steel in a house just by having all the walls sheeted with OSB.
OSB, yes.
The important thing to remember though is not all OSBs are vapor permeable. So
you've got OSB 3.
Yes. Yeah. And so OSB 3 is a vapor permeable OSB. One thing is, a lot of people say to me, oh, well, if we're going to put vapor permeable OSB that's probably airtight enough, why do we need the wraps? And it's a good question. The reason that you need the wraps is because the OSB is a shiny surface. So on the outside face of the wall, if you don't have a wrap on it, you'll get condensation forming there. Yeah. And that will be in a cavity behind your cladding.
Won't see it until it's too late.
No, no. And there'll be no cleaning it. So, you know, say you did that and you built the house and it was nice and airtight and mold formed on the outside. By the time you noticed it on the inside, you could keep cleaning it for 100 years from the inside, but you'll never solve the problem because it's just reforming on the outside.
No point doing the kitchen then.
Yeah, that's right.
Well, thank you very much for joining us today.
No worries.
Jackson, and your
Thanks for having me.
And education on the project.
Yeah.
It's been really good. So we're really keen to see how much benefit those membranes and things add to a 10-star rating as well.
Yeah,
Interrogate it.
It'll be good to see NAFAs actually include them in the software.
Yeah, well, the air tightness is in the background.
Yeah.
But whether they activate it in the next, code changes and things like that, we'll see.
Yeah.
But hopefully this will be
Kick it along.
instigating point for it.
Yeah.
So
cool.
thank you very much.
No worries. Thanks.